Welcome to another video in our series. Today we will learn how to find the inverse of a 2 by 2 matrix. So given the 2 by 2 matrix A equal to A, B, C, D, then the inverse of the matrix A is written as A to the negative 1. So that's how we write the inverse of a matrix. All right, so if it were another letter, say B, would be B to the negative 1. Now, the inverse of A, which is A inverse, is equal to 1 divided by the determinant of A times the adjoint of A. Now, you might ask, how do we go about finding the determinant of A? Now, the determinant of A is a product of the leading diagonal. So here we have the leading diagonal. So I'm just going to write LD as a leading diagonal minus the product of the non-leading diagonal, and so this we're going to write non-leading diagonal. Okay, so therefore it is A times D minus BC, and we use straight brackets here because we are the straight brackets here just to signify that we are finding the magnitude. All right, so whenever we're finding the determinant, we use straight brackets. Okay, so it's A times D, which is the product of the leading diagonal, minus the product of the non-leading diagonal, which is BC. And then to find the adjoint of A, it is equal to interchanging. So we interchange the non-elements of the leading diagonal. So interchange elements of the leading diagonal. All right. Okay, so if you notice here, we have A at the top, so A will come down to the bottom. So we're going to interchange the A and the D, interchange the positions of A and D, right? So A goes where D is, and D goes where A is. And for the non-leading diagonal, we give just change the signs. Okay. So here in the first matrix, B was positive, so it becomes negative. C was positive, it becomes negative. So we are going to just change the sign. So whatever these signs are, that we will just simply give them the opposite sign. Okay, so moving on to an example, let's look at an example. So again, to find the A inverse, it's 1 over the product of the 1 over the determinant, right, times the adjoint. And in the previous page, we looked at how to find the determinant and adjoint of a matrix. Now, so give the matrix L is equal to 3, 2, 1, 4. Now again, so the L inverse would be equal to 1 over the determinant of L times the adjoint of L. Okay, so that's how we will go about doing that, adjoint of L. So what is the adjoint of L here? First of all, let's look at the determinant of L. So it's going to be equal to 1 over the product of the lead. So the determinant is formed by the product of the leading diagonal. So the product of the leading diagonal, which is 3 times 4, and remember we use straight brackets, minus 2 times 1, straight bracket, multiplied by the adjoint. What is the adjoint? So to get the adjoint, again, we interchange the positions of the leading diagonal. So what are the positions? So elements of the leading diagonal, we have 3 and we have 4. So interchange those positions of 4 come to the top, 3 goes to the bottom. And whatever these signs are of the non-leading diagonal, we are going to switch this, we are going to give the elements of the non-leading diagonal their opposite signs. So if it's positive here, so this now becomes a negative 2, and here we have a positive 1, so this now becomes a negative 1. So let's simplify. So it's 1 divided by 3 fours will give you 12. So it's 12 minus 2 ones 2 will give you 2. Okay. Times the elements of the times the adjoint, which is merely 4, -2, -1, and 3. So let's simplify further. So 12 minus 2 is 10, so therefore this becomes 1 over 10 times 4, -2, -1, 3. Okay? This can be further broken down by dividing each element by 10 if we so desire. But once we get to this point, we have found the inverse of the matrix. All right, so it's 0.4. No, I'm going to just leave it there. All right, so once we have got to that point, we have found the inverse of the matrix. Okay. So we had 1 over 10 times 4, -2, -1, 3. And if we were to simplify that further, if we want to go a bit further, then it's going to be 4 over 10, -2 over 10, -1 over 10, and 3 over 10. Okay, and then that will be the same as 0.4, -0.2, -0.1, and 0.3. So therefore L inverse, so here we have L inverse is equal to 0.4, -0.2, -0.1, 0.3. But again, if we got to this point, then we would have found the inverse of the matrix of L. So what we're going to do further, we're going to use this concept to, in our next video, we're going to use this concept of finding the inverse of a matrix to solve simultaneous equation. So we're going to solve simultaneous equation using the matrix method. So again, I want to thank you for coming. Thank you for watching this video. I hope you have learned something today, and feel free to share the video, like it, and comment so that I can continue to work to improve on presenting you this material as you learn mathematics. Thank you.